So see here on the side, we have memory, average probability of revisiting a nectar source. Like, they just copied it right off the table, and that's what you guys will do too. You don't have to think about how to label something. Just look at the table and copy whatever the header is on the table. That's it. And then down at the bottom, they have the, there we go, get that out of there. They have the treatment. Here we have 10 minutes. Here we have 24 hours. So they separated it out based on 10 minutes or 24 hours. Now, you could have had just the control group on one side and the caffeine group on another, as long as you had one bar graph for 10 minutes and the other one for 24 hours. So there's a few different bar graphs that you could make that would be still valid. The only other thing that it also said, like this is a bar graph, they said that you could do a modified bar graph too. And what a modified bar graph is that where these bars would end up, you just have a point, and then you would have another point here. So if this is my control group, I would have a point here, another point here, and then that would be a line connecting those points. That would be fine and appropriate. But if you're more comfortable with bar graphs, just stick with those because they get you the same amount of points. And then finally, what I notice is that some students just do error bars going above, and they forget that the error bar also goes below. So make sure that your error bar goes above and below in the appropriate amount. So you're probably going to want to have your calculator there next to you if you're going to plot error bars so you know how high and how low it should go. So looking at this, at 10 minutes, is there a difference between the control group and the caffeine group in memory of B's at 10 minutes? I see some people saying no, other ones are shrugging. Like, do error bars overlap? Yeah. Then if error bars overlap, this is not a significant difference. So I cannot say anything important is different between the control group and the caffeine group at 10 minutes because my error bars overlap. That's not a significant difference. But down here at 24 hours, looking at the control group compared to the caffeine group, there is a very big difference. So between these two bars, I can say that B memory does not seem to have any impact with caffeine at 10 minutes. However, those exposed to caffeine have an increased memory after 24 hours compared to the control group. Does that make sense? Okay. So whenever you look at graphs, sometimes if you don't have to make a graph, you might have to interpret it. If you're looking for patterns or trends, the only patterns that are significant that you can talk about are ones where the error bars do not overlap. And then again, here's what they looked at. Plotting the means on the bar graph, labels and scale, and correctly plotting the error bars. So don't forget the error bars because that's a point. Here's B. Based on the results, describe the effect of caffeine on each of the following: short-term memory or long-term. So here's on short-term. Caffeine does not affect short-term memory at 10 minutes. That's because the error bars overlapped. So we don't see any effect. Long-term, caffeine improves or increases long-term memory at 24 hours. And then here's a good example of a student response. On a short-term 10-minute scale, caffeine has no significant effect on B memory of a nectar source. And when you say significant, that means something. Like if you're in stats class and you say something significant, like there's a mathematical reason behind it. And for us, it's because the error bars are overlapping, so that's not a significant difference. But the standard deviation of the control group and the experimental group overlapped. So that's why it's not significant. Identifying hypotheses. Did I skip one? I must have. So looking here at C, designing an experiment using artificial flowers to investigate the negative effects of increasing caffeine. Let's look at the key for the first part of C. Oh, no, this is what they want you to do. Okay. So, as you're designing that experiment, they want to see that you did like a couple things. You designed an experiment, but then you identified the null hypothesis. So the null hypothesis that you have to identify is that it's a no effect hypothesis. So when we're doing chi-square or designing experiments, the null hypothesis is always the no effect. When you design your experiment, you would need to have a control group, which means that you would have to have a group with like flowers or nectar that did not have caffeine. How you design that might vary widely, but that's what they're looking for, is that you have a control group and that you like discuss some of your predicted results. Maybe the number of visits by bees is different with increasing concentrations, or it's different than the control. And in this student's answer, like they must have talked about different levels of treatment. So that's where they got the 0.9 molar caffeine from, because that was in their experiment. Okay, here's D. D talks about the benefits to plants that produce nectar with caffeine, and then it talks about the cost to the bees. So in the question stem, it says that researchers found that nectar with caffeine has a lower sugar content than nectar without caffeine. So plants use less energy to produce that nectar with caffeine. So the benefit to the plant would be either one of these two different things. Bees are going to need to visit them more often. So they're going to have more of their pollen transferred by those pollinators, by those bees. Another benefit would be that they're going to have more energy available to themselves that they're not putting into the nectar. So either one of those would have been fine for the plant. The cost to the bees, they're going to have to visit the flowers more often. That means that they need to use more energy to visit the flowers more often. If there's less sugar, then they're not going to be able to make as much honey. Or that their honey would be like of a lower quality. Any of those would have been fine. But they're picking up all of those benefits and costs from either the question stem or from the background that they gave you initially. I just want to make sure that when you guys justify things with evidence, you're always going back to the text or the graph or the table. The biggest mistake I see students making is that they like go with their gut. Scientists don't go with their gut. They go by like evidence that's before them, and it's a commanding evidence in front of you that they're actually looking at. That's been the biggest issue on AP Science tests, or not using the evidence provided. That's been the biggest issue on the SAT as well, is like the command of evidence provided. Do you guys want to switch focuses a little bit? You want to move around? How about for this question? Why don't you guys take some markers and go to tables, and like you guys need to move around a little bit. Right.